Engineering 305, example problem 3.7. A strain rosette composed of 3 electrical resistance strain gauges making angles of 0, 60, and 120 with the x-axis, shown in the figure, was mounted on the free surface of a material for which the Poisson's ratio is 1/3. Under load, the following strains were measured. So yeah, while you're looking at it, I'm going to start copying this stuff down. So the strain in the x direction was equal to 1,000 micro. And the strain in the A direction is equal to 1,000 micro. We'll talk about why I had that little slip. The strain in the B direction is equal to 750 micro, positive. The strain in the C direction is equal to negative 650 micro. And right behind that, I'm going to put all of their angles. So the strain in the A direction, that's at theta equal to 0. The strain in the B direction, that's at theta equal to 120. And theta in the C direction is equal to 60. So sometimes, yeah, when you get this data and you go ABC, and it's actually ACB if you want to go a 0, 60, 120, then our strain gauges aren't in that order, or the way they gave us the data. And that's a good reason for writing this stuff down. The other reason I'm very careful in writing it down this time is I did the problem already and my sound didn't work on the recording, so I had to do it again. But I actually wrote down the strain in the A direction is 1100. Got the whole problem wrong. So, but it was pretty easy to find out because I had it clearly written at the top of the page. The strain in the A direction is equal to 1,000. So how are we going to solve this problem? Well, first I'm going to get rid of the problem statement, and we have all the important information now still on the screen. We need the equation that we're going to work with, and that equation is that one. The strain in the n direction, is equal to the strain in the x direction times cosine squared theta plus the strain in the y direction times sine squared theta plus the shear strain sine theta cosine theta. Now, oh, 3, there we go. When theta is equal to 0, then cosine of 0 is 1. So the E in the A direction is equal to the strain in the X, which is 1,000 micro, times cosine of 0 squared, which is 1 squared. And then sine squared, that goes to 0. That's a big fat sine of 0 is 0, and sine of 0 is 0. So both of those terms go away, and what you're stuck with is EA is equal to EX, or EX is equal to EA. Ta-da! EX is equal to 1,000. I did that wrong. Start it. Let me start that over again. EN is equal to 1,000. Is equal to EX times 1 quantity squared. And then this term went away, that's 0, and that term went away as 0. And that's how I know that EX, sorry about that, oh my smidgens. That's how I know that EX is equal to 1,000. It's what the value of EA is. And that's obvious. EA and EX are in the same direction. They're oriented the same. That was a given from the very beginning. But got that. Now, EB, the strain in the B direction, that is when the angle is 120. And so that's equal to, and I'm going to write the equation again. Maybe I should just cut and paste it. That equation is, it's magical. EX, should I have already substituted in? I could have just dropped the number right in there. Cosine squared theta plus strain in the y sine squared theta plus gamma xy sine theta cosine theta. And now I want to write this down too. E in the c direction, the strain in the c direction is equal to strain in the x, and I could write that down because I know what it is. I should have put the angles in here, and I'm going to go back and do that. Oh, so I'll start doing it here. Cosine squared, the c direction is 60 degrees, plus EY sine squared is 60, plus gamma sine of 60 cosine of 60. Now, and I'm going to put, that's 120, that's 120, and those are both 120. Now here's what I want you to see. If I draw a little circle there, and this is my angle, right? There's my 60-degree angle. And okay, that's close, but that's my 120-degree angle. That the sine of theta or sine of 60 equals the sine of 120. But cosine of 60 is equal to minus cosine of 120. So what that means is it doesn't matter this term or this term because I square it. But on these terms, they're going to have the opposite sign. When I multiply those together, they're going to have the opposite sign. So if I go the strain in the B direction plus the strain in the C direction, that's going to be equal to twice the strain in the X, cosine squared 60, plus the strain in the Y, sine squared 60. And that got rid of, and here I could put plus 0 gamma. All right? And the advantage of that, hold on. Sorry, I launched some new software and I had to cancel it a sec. The advantage of that is now I'm down to, these are knowns. Those strains in the B and C direction is known. We've already solved for that. So now I have one equation and one unknown. And that makes that straightforward to solve. So I go back, I have to shrink this a little bit so I can see the top of the page at the same time. EB plus EC is going to give me a value of 100. Oh, I'm going to go back to black. 100 is equal to 2 times cosine of 60 is equal to a half. So this is 1/4 times EX, which is 1,000, plus the strain in the Y direction times the sine of that square root of 3 over 2. So 3 over, square root of 3 over 2, and then I have to square it. So it's 3/4. No, yeah. 3/4. All right. And then we just have to go through the math and simplify this. I've got 2/4 of 500, or 2/4 of 1,000 is equal to 500, plus 3/2 y, strain in the y direction. Not sure I'm 100% right here. Equals, or not equals, I got to rearrange again. I'm going to rearrange. I'm going to subtract 500, so I get 400. A negative 400 equals 3/2 of the strain in the y. And then I got to pull out my trusty dusty calculator. Yeah. strain in the Y is equal to 266 negative. I got a negative sign there. Micro. And now I know the strain in the X, I know the strain in the Y, I know the strain A, strain B, strain C, I know the angles. I just have to punch in one more time to solve, and I could punch into either that equation or this equation. Either one of those will give me the answer that I can solve for the shear strain, and I'm going to get the answer that's negative 1616 micro with the fancy pen. All right? Now, is that the end of the problem? If we read it carefully, we would see determine the principal strains and the maximum shear strain. So the first thing we had to do is we had to convert it to X and Y. Now we got to go find the principals. Well, if I'm going to do the principals, that's going to be, I'm going to wind up getting the principal 1 or principal 2 is equal to the strain in the X plus the strain in the Y divided by 2 plus or minus, what's the radius? What's the radius? Do you remember? Strain in the X minus the strain in the Y divided by 2, quantity squared, plus, that's a gamma. That's a really lame gamma. I didn't get my little loop in there. Loop xy over 2 quantity squared. And that's going to give you your two answers, and we can proceed from there. Or you could start using Ames Web and start converting them that way. That's example problem 3.7. Key for that, the key for what we did and what you need to be thinking about is we started with data from 3 strain gauges with different orientations. We plugged them into that equation 3 times. 3 times. By doing that, we got 3 equations with our 3 unknowns: strain in the X, strain in the Y, and the shear strain. And we knew the strain in the N direction and the angle for each of 3 different cases so that we could do that. Now, one of them was a dead giveaway, the E and the X, the strain in the X direction, because our A strain gauge and our X axis were aligned with each other. So that made that dead simple. And then I showed you that the 60 and 120 cancel each other. Those equations cancel, and that makes that easier as well. And then we went on, and so then we went on and we plugged in and we got our answers. Boom, boom, boom. There's our answers. I guess let me get the pixie dust and I'll circle them. That one, and then the other one was way up at the top right there. So that's good. And then from that point we can go on and do the transformations that we've been doing, whether we want to think of that as a stress transformation or a strain transformation, but we can do transformations to principal strains or principal stresses. So we're all set. Now, the one thing I'm going to add, if got to move my page, we had strain gauges that were oriented like this, bonk, 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 and I'll say this is A, B, C, and so now we're looking at 0, 45, 90 strain gauges. All right, then the strain in the A direction is equal to the strain in the X direction. That's dead simple. That's cool. So that's got, well, same, no advantage over what we just did with the 06120. But the strain in the C direction is equal to the strain in the Y direction. So now you're down to one unknown, the shear strain, and you can get that by writing one more equation which incorporates B, or actually incorporates any of them. No, it would have to incorporate B. And then you can get the shear strain. So that's cool. Got that going for you. Those are the 2 types of problems we're going to have, either a 04590 or a 06120. Those are the way strain gauges are made. I'm sure, there's possibilities that you could make others, but I haven't seen them. So there you go. Hope you're doing well. See you in class tomorrow.